We are now going to go through this example. So it says, on a construction site, there are 4 cranes and each must be allocated to one job. The time required to set up the crane and then complete each job is shown in the table below. Find the best assignment of cranes to job so that total time required for completing the job is minimized. State the total time taken for the cranes to complete the jobs. All right. So here it is right here. We've got the cranes and we've got the jobs. And what we've got to figure out is the minimal amount of time to get all of this done. Now, you might think to yourself, I reckon I can do this by inspection, but it's actually harder said than done. So, or easier said than done, or whatever the saying is. So if you look here for a moment and you say, all right, I'm going to try to do this, and I wouldn't recommend you write this down on your sheet. You might say, all right, crane 1 should probably do job 2 because it's the shortest amount of time there. And then looking through this as well, 3 is a pretty short time. Maybe crane 4 should do job 1. And then crane 5, it can't do job 1 because that's already taken by crane 4. So the next smallest number would be here. So crane 2 would have to do job 4. But then that leaves us with crane 3 doing job 3, and that gives us 10. Now, can you be sure that that's the best way? You know, there's so many different ways to do this, and that's why the Hungarian algorithm is so useful here, because in actuality, this isn't going to be the right answer. So let's rub that out and let's talk about how we're going to approach this and how to use the Hungarian algorithm. Try to do this as neatly as possible because there are a lot of steps, and I'll try to write nice and small so we can fit all this in. But do be aware, we're about to fit a lot into this page right here. Step 1, we need to create the cost matrix. Okay, when creating the cost matrix, it's literally just taking this and writing it out into a matrix form. So I'll come here like this, and I'm going to write it out. So it's going to be 16, 5, 8, and 3, 2, 13, 6, and 4, 3, 7, 10, and 5, 7, 6, 9, and 11. That is step 1. We then go on to step 2. All right, step 2. What is step 2? Step 2 is row reduction. Again, make sure you're writing small because we're going to try to fit a lot into this. All right, row reduction. We come here, we do this, we do that. Remember, what you want to do now is find the smallest number in each row. So 2, 5, 6, and 3. That looks like they're the smallest of each. So now we're going to go, all right, I'm subtracting 2 from this row right here. So I'm going to go 16 minus 2 is 14. I'm going to go 2 minus 2 is 0. I'm going to go 3 minus 2 is 1. 7 minus 2 is 5. And then follow the same process. So now 5 from this row. So this is going to be 0, 8, 2, and 1. And then again, 6 from this row. 2, 0, 4, and 3. 2, 0, 4, and 3. And then the last one, 3 from this row. 0, 1, 2, and then 11 minus 3 is going to be 8. Okay, having now done that, we now go on to our next step. So once you've done row reduction, what's the next step? Step 3. It's going to be column reduction. Column reduction. So we'll draw this. We'll draw that. All right, so this time what I want to do is I want to look for the smallest number in the column. So that's going to be 0 for this one. It's going to be 0 for that one. For this one, it will be 1, and for this one, it will be 1. Now, remember, when you have a 0 in the column, it means that you're not going to subtract anything, are you? You're subtracting 0. So 14 minus 0 is 14. 0 minus 0 is 0. 2 minus 0 is 2, and so on. Same logic for the next column, 0, 8, 0, 1. But for now, for this column here, we're subtracting 1. So it'll be 0, 1, 3, 1. For this one, we're subtracting 1. So it'll be 4, 0, 2, 7, 4, 0, 2, 7, 0, 1, 3, 1. Perfect. All right. Having now done that, so we've written our cost matrix, we did row reduction, we did column reduction. The next thing that we want to do is draw in our lines. So we're going to move it all the way here. And I'm just going to redraw that matrix. And actually, we'll give it a title again. Look how neat our working out is. It's beautiful. So what we're going to do now is the line method. Again, try to write small because we're going to have to fit a bit more into this page. So we'll come here. All right. So now I'm just going to rewrite this. So it's 14, it's 0, it's 2, it's 0. It's 0, it's 8, it's 0, it's 1. It's 0, it's 1, it's 3, it's 1. It's 4, it's 0, it's 2, it's 7. And now what I'm going to do is I'm going to try to draw lines through all the zeros and also try to do it as minimally as possible. Now, there are different ways of going about this, so there isn't just one right way. But what we need to think of is that we're in a position where we have 4 tasks, don't we? So that means we need 4 lines. So let's write this down. Therefore, we need 4 lines because 4 lines needed, all right, for allocating 4 jobs. So if we can't get 4 lines, we need to do it again. We need to go through another step, and we'll talk about that step if needed. All right. I can cross out 2 zeros by drawing a line there. I can cross out 2 zeros by going through a line there. Now I've still got a 0 here and a 0 here. That must mean I have to do this and this. So that means I need 4 lines to cross out these 4 zeros. So that means I'm done. So this means I have reached my allocation matrix. So I'm going to write allocation matrix is found. Allocation matrix is found. All right. So now what I'm going to do is I'm going to come here and I'm going to write in what my allocation matrix is. So we'll come here, we'll go there. And my allocation matrix is just going to be this. So it's going to be 14, 0, 2, 0. It's going to be 0, 8, 0, 1, 0, 1, 3, 1, 4, 0, 2, 7. Do this, do that. Okay, and we'll write this in. This is my allocation matrix, people. This right here, this is the allocation matrix. This tells me who's going to get which job. Okay, how do we read off our allocation matrix? This is the way it should be read off. So remember, we've got crane 1, crane 2, crane 3, crane 4, and we've got job 1, job 2, job 3, job 4. So the way you read this off is like so. You go, all right, is there any row here with only 1 0? There is. Crane 4 has to do job 1. Crane 4 has to do job 1. Then, is there anything else with only 1 0? Yeah, crane 3 has to do job 2. And now from this, you can say, all right, if crane 3 is doing job 2, that means crane 1 can't do job 2. That means crane 1 has to do job 3. And then also, what's crane 2 going to do? Well, crane 2 can't do job 1 because that's already taken by crane 4, and the only other option is job 4. And just like that, we have now been able to figure out our allocations. So now we can come here and we're going to do our final allocation. And we can write this out. What I'm going to say is I've got crane, I'll write crane. Crane 1, I've got crane 2, I've got crane 3, I've got crane 4. Which job is each of these going to do? This is going to do, well, looking up here, crane 1 is going to do job 3. Job 3. Crane 2 is going to do job 4. Job 4. Crane 3 is going to do job 2. Job 2. Crane 4 is going to do job 1. Job 1. And just like that, 3, 4, 2, 1, I've now figured out my allocations. We also need to figure out the optimal time here. So we'll come here, we'll write down, what is the time needed for each of these? Now this is where we're going to have to read off our original graph here. So I'll come up to my original graph, and this is how we're going to read it off. We're going to go, crane 1 has to do job 3. I'll try to keep the colors the same here, just to keep everything pretty. Crane 2 has to do job 4. What else do I have here? I've got crane 3 has to do job 2. And then last one, but certainly not least, where's my blue highlighter? Crane 4 is doing job 1. Okay, wait. Here we go. All right, so now I can write these all down. I'll do them in red. So crane 1 is taking 3 hours. Crane 2 is taking 6 hours. Crane 3 is taking 6 hours. And crane 4 is taking 3 hours. So that means, where can I put this so that it's pretty? So we can write down hours here, just so we all know that this is saying the amount of hours. And now what we're trying to figure out here is what the minimal amount of hours. So the total time taken for the crane's job to be completed. So we can say, therefore, well, I need this room to do something else. We can say, therefore, we'll do it in a different color. Do it in black. Therefore, time taken is 3 plus 6 is 9. 9 plus 6 is 15. 15 plus 3 is 18. That's my final answer. Time taken is 18, like that. Also, remember, they might ask you to show your information as a bipartite graph. So in that case, what would you do? Well, in that case, if they ask for that, you'd have to kind of, let's divide that up. How good looking at these notes. All right, we're going crane 1, crane 2, crane 3, crane 4. Okay, and we put a vertex on each of these. Then we've got job 1, job 2, job 3, job 4. Put a vertex on each of these. Now we need to link them up. So I'm going to say job 1 is going to, crane 1 is going to job 3. I'm saying crane 2 is going to job 4. Does it look like that? Crane 3 is going to job 2. It's going like that. And crane 4 has to go to job 1. Try to put your arrows in nice places so you don't get those that mess. Oh, I just ruined it. Like that. Crane 1 was going where again? Crane 1 was going to job 3. And then crane 3 was to job 2. Perfect. Let me just double check that because I'm worried that I messed it up once I redrew it. Crane 1, job 3, crane 2, job 4, crane 3, job 2, crane 4, job 1. We are done, people. That is how you do it. So as you can see, our Hungarian algorithm allowed us to achieve this. Now, did you notice that we immediately got to 4 lines the first time we did it? If that didn't happen, we would have had to have done, if we come all the way back here, this step right here. So remember when we were doing it, when we got to step 4 and we were crossing out the lines, we didn't actually achieve those 4 lines for 4 tasks. So what we had to do is go to the lines that were left, go to the numbers that were left over, find the smallest number, and then subtract. So our example here didn't involve step 5 here. So in your exercise, you might come across having to need that step, and hopefully you're able to do that successfully. All right, hopefully you found this helpful.